Let's take a look at page 16. Page 16, now we're finding the least common multiple again, but it's of more than two numbers. So to find the LCM of 3 or more numbers, here's what we do. It gets a little more complicated. Make sure that you're feeling pretty good with the least common multiple of 2 numbers before you dive into this one. So feel free to go back to that last video, watch it again, because you'll want to be comfortable with that. This is similar. We draw an upside down division sign with the numbers inside separated by commas. And we're going to take the largest number, just like before, that divides into all the numbers inside, write it to the left of the division sign. Now here, remember, we have at least 3 numbers. So maybe there is no number besides 1 that works. In that case, skip to step 5. If not, take out that whatever it is, maybe it's a 3, maybe it's a 15, divide and drop the quotients down below the numbers. And repeat steps 2 and 3, so just keep doing this over and over, until the biggest number that goes into all of them is 1. Once you're done with that, or maybe you skipped there straight from step 2, you're on step 5, and now we're going to take a number that divides at least 2 of the numbers inside. Maybe it divides 3 of the 4 numbers inside, but it needs to divide at least 2 of them. Write it to the left of the division sign. We're going to be a little careful here. This part's a little different. We are going to divide any numbers that you can that work out evenly by that number, put the quotients below, and then drop the remaining numbers down unchanged. Now this, let's go ahead and take an example. Let's look at 15, 40, and 60. Okay, 15, 40, and 60. We are going to take out, well, what goes into all of those? 5. Take out a 5. 5 is prime, but it doesn't matter. If 15 had gone into all of them, I would have taken out a 15. Or I can do it in multiple steps. Either way, 5 goes into 15 3 times, into 4 8 times, and into 60 12 times. I don't see any numbers that divide into 3 and 8 and 12 besides 1. So I go down to step 5, and I look at a number that divides at least 2 of those. And I see, oh, 8 and 12. Could say they have a 2 in common, or I could even say they've got 4 in common. The 4 will get me done a little faster, so I'm doing that. Now, step 6 says divide any numbers that you can by that number. 8 divided by 4 is 2. 12 divided by 4 is 3. But 3 divided by 4, I don't want a messy fraction. Turns out what we do is we just drop it down without changing it at all. So we have a 3 here. Now, I'm going to take out the largest number, so I'm repeating steps 5 and 6, and I say, wait a second, I could take out a 3, and maybe I notice the 3 first, and then I'll notice the 4. We'll get the same answer either way. 3 goes into 3 once, doesn't go into 2 evenly, so we'll just drop that 2 down, and again it goes into 3 once. 1, 2, and 1 are relatively prime. There is no number that goes into more than one of those besides the number 1. So I'm going to figure out my LCM. I'm now on step 8. The LCM is, oops, forgot our 1. And then the LCM is the product, just like before, we multiply them all together, of all the numbers along the left and at the bottom. So I have an LCM of 5 times 4 times 3 times 1 times 2 times 1. And I happen to notice that that's 120. So there we go. Let's try that again. 120. Okay, let's look at some more examples. So that was just kind of our demo. Example 1, we've got 4, 6, and 8. What goes into all of those? Well, 2 does. 2 into 4 twice, into 6 3 times, into 8 4 times. What goes into all of those? Nothing besides 1. So what goes into 2 or more? 2 and 4 they're both even, so 2 goes into those. Divide the numbers that can be divided nicely and drop the others straight down. 1, 3, and 2. Those are all relatively prime. So our LCM, 2 times 2 times 1 times 3 times 2. And I'm okay if you drop the ones there. We're going to get 24 as our LCM. 4 goes into 24, 6 goes into 24, 8 goes into 24. Example 2, let's look at 12, 18, and 24. And I'll have you work through this one. I'll give you a hint. There are a number of things that you can take out as your first step. It doesn't matter where you start. You could say, hey, they're both even. You could say, hey, they're both divisible, or excuse me, all even. Or they're all divisible by 6, or they're all divisible by 3. No matter how you do your first step, you just kind of keep going until you get something that does not have a common factor for all 3. And then you do your dropping things down that don't show that factor. Just to give you the answer to check your work, so feel free to pause it and do that. The answer is 72. 12 goes into 72, so does 18, so does 24. No smaller number works. Example 3, let's do 15, 20, and 25. Example 4, we'll do 4, 8, and 15. And let's do example 5 together. I'm going to get some big numbers here. 54, 78, and 96. Now look at that. Well, they're all even. Let's take out a 2. Makes the numbers a little smaller, and then I'm more likely to see what I'm looking for. 2 doesn't work because those are odd. What about 3? 2 plus 7, well, 27. Sure, that works. 3 plus 9 is 12, so 3 goes into that because 3 goes into 12. 4 plus 8 is also 12. So yeah, I can take out a 3. I'm left with 9, 13, and 16. Now what goes into all 3 of those? Nothing except 1. What goes into at least 2 of those? Well, 9 and 13, 13's prime, and 13 doesn't go into 9. So that pair is relatively prime. That pair is relatively prime, and 9 and 16, also relatively prime. We found a set where we're done. We didn't even have that kind of steps 5 and 6. We could skip straight to finding the product, which is 11,232. Like I said, got some big numbers on this one. Give you one more example. Let's go ahead and do 12, 15, and 20. 12, 15, and 20. And I'll let you do that on your own.